So in this video, we're going to conclude Section 8.1 with 3 more examples involving an application called percent of change. So we define the percent of change as the amount of change divided by the original amount. Or we can say that is the new amount minus the base amount. Base amount and original amount are the same thing, divided by the base amount. Now this will give us the decimal answer, and then we'll have to convert that into a percent. Okay, so the percent of change equals the amount of change divided by the original amount. Now there's generally going to be 2 kinds of percent of change problems. There will be percent of increase and there will be a percent of decrease. So generically, again, we call that the percent of change. So something's going to increase by a given amount and we're going to change that to a percent. Something may decrease by a general amount and we're going to change that to a percent. So let's take a look at example 7. In 1991, the cost of mailing a 1-ounce letter was 29 cents. By 2019, the cost was 55 cents. What was the percent of increase? Well, to find this percent of increase, again, that's a percent of change, we're going to find the amount of increase, or the amount of change, and we're going to divide that by the original amount, the base amount. So if we find the amount of change, well, in this case, it changed from 29 cents to 55 cents. So we're going to take our new amount, 55 cents, minus our original amount, or our base amount, 29 cents. And if we take 55 cents minus 29 cents, that is a 26 cents change. So it's increased by 26 cents. So the percent of change is going to equal the amount of change, 26 cents, divided by the original amount, which was 29 cents. Our original amount, or our base amount, was the 29 cents. So notice that the units cents will cancel out, and we'll be left with the decimal equivalent of the percent. If we take 26 divided by 29, that gives us 0.8965. So actually, if we round that to 3 decimal places, that will be 0.897. So this is approximately equal to 0.897, which will be 89.7%. So from 1991 to 2019, the cost of mailing a 1-ounce letter increased by 89.7%. So we say that we have an 89.7% increase. So there is the answer to example 7. Let's take a look at example 8. At the start of January 2020, the Dow Jones Index was 29,551. At the end of March 2020, the Dow Jones Index was 21,917. What was the percent of decrease? So this time we have a percent of change problem, but we have a decrease instead of an increase. We work the problem the same way though. So our amount of change is going to be the new amount minus the base amount. So that's going to be 21,917, that's a new amount, minus the base amount, which is 29,551. So if we do that, 21,917 minus 29,551, that is negative 7,634. The fact that it's negative means it's a decrease. So we had a decrease of 7,634 points in the Dow Jones Index. So we're not going to really worry about that negative. We'll just know that means it's a decrease. So our percent of change, in this case it's a percent of decrease, that's going to equal 7,634, the amount of decrease, divided by the original amount, the base amount, which was 29,551. So if I take 7,634 and divide by 29,551, that is 0.2583. So if I round that to 3 places, that's 0.258. Or that would be 25.8%. And again, in this case, it was a 25.8% decrease. So over the first 3 months in 2020, the Dow Jones Index decreased by 25.8%. Let's take a look at example 9, which is a little bit different from examples 7 and 8. So during a sale, the regular price of a pair of jeans is decreased by 35%. What is the sale price of jeans? Well, in this particular case, we have our original price, our base price, and that price is decreased by 35%. So what we're going to do in this problem is we're going to find the amount of decrease, and the way we find the amount of decrease is the same way that we did previously with the percent equations. And then once we know the amount of decrease, we can subtract that to get the sale price. So the amount of decrease in the price of the jeans is going to be 35% of our base amount. So that is just going to be 35% of the $55. Now 35% as a decimal is 0.35, so I'm going to take 0.35 times the $55. So 0.35 times 55, that is $19.25. So the price is decreased by $19.25. So to get the sale price, that's going to equal my original price, my base price, minus the amount of the discount. So that's the discount. So my base price is $55, and I'm going to take off the discount, which is $19.25. So 55 minus $19.25, that is $35.75. So the sale price for the jeans is $35.75. So for this problem, I figured out the amount of decrease, which in this case was a discount, and then I subtracted that from my original amount, or the base amount. Now we could do the same kind of problem. This is our last example for this section, but we could do the same kind of problem if we were looking at an amount of increase. So if we were talking about something like a markup, so maybe like the store purchased the jeans for $55, but they mark it up 35%. Then you would do the same thing to get the new price. You would just add instead of subtract. So you would have the base price plus the markup, and that would give you the new price, the marked up price. So again, it's basically the same idea. You just may subtract if it's decreasing or add if it's increasing. I hope this helps. Now you should be able to handle the Section 8.1 homework.